Hello, everybody. Welcome back to Math 100, Liberal Arts Mathematics. So this is lesson number 12, the beginning of a new chapter. Chapter 5 is on statistics, and this lesson, lesson number 12, and 13 and 14, three lessons are all about statistics. We will learn how to use statistics, how statistics can be abused, what some of the basic terms are in terms of statistics. This is another very, very important area, okay? There is no area in life that statistics is not used. And I don't think this is an exaggeration when I say this. Basically, every major decision, every government policy, every, virtually everything, the decision is made on basis of statistics and data. And so I cannot emphasize this, this topic of statistics enough. Okay, we have an entire course called Statistics Math 140. And so, and many people are taking that. We have over 40 sections every semester. And so we will definitely not be able to cover everything in statistics, but for these three lessons, I hope, will learn the basics of statistics. All right, so here we go. Lesson number 12. Okay, so lesson number 12 is as I said just now, the first of the three lessons we will do on chapter 5. All right, so maybe I'll write this down. And instead of actually writing things as I normally do, today I'm going to be typing a lot because we have lots of words that we need to define in terms of statistics. All right, so lessons 12, 13, and 14 are for chapter 5, and then the topic is statistics. All right. So as you do your homework, you do lesson number 12, and then lesson 13, lesson 14, and then you turn in your homework for chapter 5. All right. I have a few questions here. What is your favorite color? What is your job? What is your date of birth? And what's your IQ and income? How tall are you? What is your weight? All these questions are trying to gather information about you, and and some of these data are different of different type, and we'll talk about these things. The main question today is how can well, no one do this here, but how can I determine if a statistical study is valid or makes sense or reliable? And the key word here is the word reliable. Okay, because there's lots of statistics out there that may or may not be accurate. Right? What should I look for when I read a statistical study? Okay, because again, you have to have critical mind, and you have to look at and read things critically, because people try to convince you of all sorts of things. All right, and so how can you be discerning when you read a statistical study? That really is a key an idea or key topic in this, maybe it's a goal of these three lessons. All right, so I'm going to introduce you to a bunch of terms here today, and so you will need to know these basic terms of statistics in order to understand and discuss statistics. Okay, so first I should say, you know what, maybe I'll write some words down here, and maybe writing this better for me, right? Okay, so the first thing I want to say is this word statistics. Statistics, the first thing is you have to learn how to spell. All right, is this a singular or plural word? Okay, and the answer is it depends. Okay, it can be singular, and let me introduce to you the singular noun statistics with an S at the end. All right, so the word statistics refers to the science or the branch of mathematics of collecting, organizing, interpreting data to draw conclusions. Right, so this is an important part here. We just don't collect data for the sake of data, but our goal is to draw some kind of conclusion. Often in real statistics class, you learn about an hypothesis test, and that is a way to draw conclusions based on data. Right? So that kind of science, of gathering data in order to make conclusions, that's called the discipline of statistics. Okay, many schools do have a department of statistics, and that's so it is a branch of math or a part of science or the discipline. Okay, and so that is one thing, and this word will come back again as a plural word. All right, let me explain this word population. Okay, so when you start to collect data, you want to know something about some group of people or things. Okay, and so the entire set, and sometimes it's called a universe or universal set, is the population. The population is the entire set of things or people being studied, right? So this is the group of which you want to know something. Now, this is often too big. Okay, let me just give you an example of this, right? So let's say you are trying to understand, maybe you want to find out height of all Americans, okay? And maybe you're doing a global study and trying to find out, are Americans taller than other people? What is the average height of all American people, right? And the answer, first of all, the truth will never be known. Okay, there's no way for you to know that. But when you do this, you will collect data from some sample, some subset of all Americans. Okay, well, in this case, all Americans is the population, because you want to find out something about the entire country or the entire set of American people. And so that would be called the population. All right. Like I said, this is often too big. Okay, you will not be able to collect information from every single American person at the same time to be accurate. There's no way you can do that. So what we do is to collect or to identify a sample. This is also a singular word. A sample, it's a set of people. And in fact, it's a subset collected from your entire population. All right, so here's the picture. You have this population and you want to know something about this population, maybe how much they're making, how much they weigh or whatever. Okay, and it could be a group of people or things or plants or some sort of animals, whatever. Okay, but because that is often too big, you take a sample. Now, again, the word sample does not refer to individuals in here. Okay, one sample is this collection, a subset of the population, all right, from which the data is collected. And it should be free of bias. Okay, so you do not want to end up with a biased sample. If you have a biased sample, everything that you do after that is going to be flawed. And whatever you do after you collect data from the biased sample, it's no good, right? So you want to pick your sample very carefully. And I'll talk about the method of collecting or gathering these individuals, in the sample. How do you pick a good sample? And that turns out to be a very, very difficult challenge, right? A true value about the population. Okay, let me go back to this idea of height, the average height of all Americans, right? There is the average height of all Americans. I don't know what that is. You don't know what that is, okay? But there is a true value, and that value about the population is called a parameter. This is what you're looking for, okay? This is what you're looking for, what you're after, what you want to know. Okay, unfortunately, speaking in a philosophical way or in epistemological way, there is no way to know this. Okay, there's absolutely no way for anybody to know for sure exactly what the parameter is. What is the true average of all Americans? Are we talking about today? Yeah, today. Well, there's no way to find that out, right? And tomorrow it's going to be a different value. So we can hardly ever know this. So what we do is we estimate, and that's the best we can do. And we can do this in a very, very a good way, right? How do you estimate this parameter? Well, we collect a data, and that data, so let's say you collect a bunch of height information, the height data from all Americans, not all Americans. You pick a lot of people, hopefully by an unbiased sample of all Americans, and you check their height, and you gather that data, and you take the average of those numbers. What do you get then? Okay, that is an estimate. And that estimate, listen carefully, this estimate is called a statistic. Statistic, right? A singular, right? And so without an S. And if you have an S, statistics, you're talking about more than one of those numerical values, right? So each one of those numbers based on the sample data that you gather is called a statistic. If you have two data figures, then it's called statistics. If you have a whole bunch of them, you can call them statistics, but each of them is called a statistic. Okay, so this is used in a different sense from this first term, the first time I used this. Here, we are referring to the discipline of statistics, just like mathematics and physics. You know, some of the disciplines end with an S, but that's a singular word. Right? And here we have, without the S, a statistic, and that refers to the estimate or to an estimate that is based on the data set. Okay, a numerical value calculated from raw data is called a statistic. So here's an example, right? Let's try to find the true average American, a true average height of all Americans, right? That true average is the parameter, right? Okay, that is the thing that we want to know, okay? And so what do? Well, we take a unbiased sample, and find the average, okay? And that average is the statistic that we can find, statistic. All right, so let's say you found a good representative sample. And by the way, unbiased can be also called a representative sample, okay? So that means, you know, we're trying to cut the bias as much as possible. I mean, people can argue, can there be a completely an unbiased sample? And the answer is probably no. But the big question here is, you know, how do you try to get the bias to be minimum? And so that is a pretty difficult task, as I told you. Okay, but once you collect the data from the sample and you take the average of those values, and that becomes your statistic. Okay, so what will you do? What do we do? So we use a statistic or statistics to estimate the parameter, which belongs to the population. So here's a picture of this. All right, so you have this population. Okay, again, it's a universal set, and you want to study something about this universal set, right? And this is way too big. So what we do is we take a sample. Okay, if you're talking about all Americans, you make sure that you have, you know, you include males and females. Probably you want to have somebody from each state and from different ages, whatever. Okay, so you take an unbiased or representative sample. And this is the group that you study, and you obtain some data, and you calculate, you do some calculations, and you get a statistic, right? And then this will give you an estimate for the parameter, which you will never know for sure, but you can have a good estimate based on this statistic. And then this parameter is going to give you some information about the population. All right, so this picture, I think, is a good thing to keep in mind so that you can understand all four of these terms. These are four important terms on statistics. All right, so we have many methods of sampling, right? Collecting the sample, but or I should say identifying a sample. Right? Remember, a sample is this subset consisting of many people, hopefully. Right? So how do you identify? How do you sample? And there are basically four ways. There are many more ways, but you can classify them into four major types of sampling. Make sure we avoid bias as much as possible. All right, some of them are better than others. All right, so number one, this is the best, random. How do you do this? Okay, that's also a very difficult question. Random sampling is a sampling method where everybody in the population has equal probability or chance of being picked. Okay, so if you have, let's say, all Americans, that would be like 330 million people. Somehow, if you can come up with a way to generate random numbers so that every person in America has exactly the same probability of being picked to be included in your sample, okay, that would be called a random sampling method. That's probably next to impossible, right? But if you could do that, that's called random sampling. Now, random is great because there is no bias, right? I mean, there's some sort of randomness, which just means that the sample you get will be representative, right? That's one way to do that. Sometimes you want to depend on something more systematic, okay? Systematic sampling. What is systematic sampling? Well, that's when you pick something like you use a pattern or a system. Like, let's say you pick every 10th object that comes out of a assembly line, right? So let's say you have an assembly, you're working on an assembly line, you are a person of quality control, and a bunch of these, things are coming out of the assembly line. Let's say you're creating a car part or something, maybe what do you want? A pedal or a doorknob or something, and a bunch of these are coming out, and you're supposed to be checking their quality, right? It's impossible to check every one of them coming out. Maybe it's not so efficient. You don't have to check every one of them for defects. So what you can do is to pick every 10th one or every 100th screw that comes out, or whatever, right? So when you do that, if you pick every 10th object or every 100th person that you choose, you get in contact with, or something like that. And so that, let's say every nth object or person is chosen to be in the sample, okay? That would be called a systematic sampling method, all right? You could also do, and this is also important, stratified. All right, the stratified sampling means that a certain number called quota is chosen from every subclass. Okay, now this is important if you have, for instance, both men and women. If you want to know something about all Americans, certainly you don't want to exclude entire the group of men or women, right? So let's say you pick 10 men and 10 women from each state. Okay, so that would be a pretty good representation of America. Right? You could people from each state. And of course, you can argue, is this really an unbiased sample, because some states are much bigger and you're still taking the same number of people from each state. And, you can argue and debate, is this a representative set? And so that depends on what you're looking for, okay? But anyway, if you do that, if you make sure that every subclass is represented in your sample, this is called stratified sampling. Right? And then the final one, convenience sampling. This is probably the worst way of sampling, but sometimes that's the only possible way. And that just means whatever is convenient or possible, right? And so, for instance, if you are taking a voluntary survey, just let's say you are picking all your neighbors, okay, neighborhood survey. Okay, you let's say you're interested in what is the most popular car people drive in our city? You don't have time to go visit every place in the city, so you just check your neighborhood and you say, oh, you know what? In my neighborhood, Ford is the most popular brand of cars, and therefore Ford is the most popular brand in our city. Well, you can't really say that, right? But that would be a convenience sampling, because you are just you're just sampling based on your convenience, right? And so random is the best. Okay, convenience is probably not the best. It's probably the worst of the four, but sometimes that's the only one that we can, you may be able to conduct. All right. So the types of data. All right, and there are two words that you need to know. One is quantitative, and the other is qualitative. Unfortunately, they sound very close to each other, but they both start with QUA and end with TIVE. Man, I wish they were slightly more different, but they aren't. Okay, so what is quantitative? Okay, quantitative, it's numerical. Okay, not just numerical, right? But calculations are possible. What do I mean by that? Okay, so for instance, if you're trying to find the average age of college students, for instance, what's the average of all the students enrolled in your school, in your college, right? That would be numerical data, and that would be quantitative, because what you can do is you can collect all that information, right? And let's say you picked, 3,000 students and found their age, and you can actually calculate. See the calculate? You can actually calculate their average, right? So that average is called, of course, the statistic in this study, and that the calculation makes sense. And so that would be an example of a quantitative data. All right, what is qualitative? A qualitative is where you can't do calculations, okay? Can't do calculations on this type of data. So what are we talking about? What is your favorite color, for instance? Okay, because you can't really numerically, calculate the average of colors, for instance, right? Remember the examples I was asking you, or an example I asked you at the top. What is your favorite color? What is your job? Right? A job. Okay, again, you don't have an average job. I mean, you can talk about it, but if you get 500 different types of jobs, you can't you can't order them, you can't calculate in any meaningful ways. So that would be that. Date of birth. Now, this is you have to be careful here. Date of birth is numerical in a sense, right? You can write the birth date as a number or a month and a number, but really there's no way to average them out, and average doesn't really make sense. Okay, so the date of birth is also a qualitative type of data. All right, so these are qualitative. Let's go back to these questions here. Your job, your color, the date of birth, or your favorite color, your date of birth. These are qualitative. What's your IQ? Okay. What's your income? How tall are you? What is your weight? Okay, so weight in pounds maybe, or kilograms. How tall are you in inches or in centimeters? What is your income in terms of dollars? What is your IQ? You see, all of these can be used in calculations, in meaningful calculations, to find average and so on. So these are quantitative. Okay, so that's the difference between those two. And so just be aware of that difference. And by the way, some of these questions you probably would not want to answer, right? Especially if a stranger comes and asks you, right? So because people don't want to give information, especially in age like the society and the age that we live in. So we'll talk about that, how some questions make people uncomfortable and you don't get the correct information. And that's really our next topic here, the types of bias, right? And I will just mention, and you should know these two types of bias. One is called selection bias, and the other is called participation bias. Okay, so selection bias and participation bias. Okay, let me just call this 1 and 2. All right, so for instance, what is a selection bias, right? If you ask only a certain kind of people, right? So this has to do with the bias in sampling. I mean, the most, like a very silly cases, like let's say, somebody comes from overseas and say, you know what, America, the baseball is a really big sport. I wonder what what team American people like, and so this person goes to Los Angeles, right, and Hollywood, stands in Hollywood, and asks people, hey, what kind of what baseball team or teams are your favorite? And you say half the people say the Dodgers, and the other half says Angels. And so the foreign tourist goes home and says, you know what, all Americans love the Dodgers and the Angels. And you say, well, that's stupid, right? Because if you sample people in LA, that may be the case, right? But that's not true for the entire country. That is a selection. That would be selection bias. So that would be an example of selection bias. Bias based on sampling, right? So for instance, if you pick just the older people to represent the entire country, or only males to represent the entire country, or if you just pick only a certain geographical location, like if you go to the airport to study what kind of cars people drive, that's not a good representation of all the cars in the city, right? So bias in sampling, geographical, maybe population, if you pick only the males in a study to represent everybody and so on. Okay, so that would be that. And the participation bias. Okay, so this is like this is when people can say no to a survey. All right, some people won't answer. Now imagine walking up to someone and says, "Hey, what's your weight? Or how much do you weigh? Or how old are you?" Okay, many people will just probably ignore, and this is becoming more and more of a problem. 30 or 40 years ago, there were lots of surveys done on telephones. Right? People, with landlines, so you call these phone numbers, and the phone numbers are generated randomly from the phone book. And by the way, there was a time in American history, not so far, fairly recently, when almost every phone number was found in the phone book, like the physical phone book. And so you can generate a random numbers so that the machine can pick random numbers, and you call them, and people actually pick up the phone and answer these surveys. That was good. That is hardly ever done anymore because most people just wouldn't pick up the phone. Okay, and of course you can understand why. So that would be a participation bias. Okay, now here's another example of this, and maybe I'll just write this down. You can remember this. Hotels and restaurants. Okay, and for instance, if you go to a restaurant, okay, sometimes you see on the table a little survey like how do you rate us? And well, there's a table, and so do you ever fill out these things if you go to a table? If you go to a restaurant, um, probably only when you have like terrible service, right? Or maybe extremely good service, and you just want to tell people, hey, I'm really, really impressed with your service. But most likely, people with very strong opinions are the only ones that fill out this survey. That is an example of participation bias, okay? Because only certain people participate. Okay, most people will not, and so that would give you a certain type of bias, and you could probably hear like people with extremely angry complaints. Okay, and but that does not mean that everybody that goes to the restaurant has a terrible time. It's only those who decided to participate, and that would be participation bias. So I'm not writing down all the details, but remember these two types of bias, or some people call it biases: selection bias and participation bias. All right, in survey questions, you have to be asking questions carefully. Right? Poorly worded questions. We have a name or term for this. Loaded questions. What are loaded questions? These are the questions that are poorly worded, and you will not get good results or unbiased results, because these questions, loaded questions, lead one to a certain type of biased answer, right? Do you favor a tax increase? Right? Well, that's sort of fair, right? How about this? Do you favor a small tax to hire more police officers to ensure your safety? You see what's going on here? This is a very different question from the first one, because you're almost led to say yes, because you have words like safety, ensure safety, police officers. Well, that is a debate. But anyway, this is a loaded question, because you can see that there's a tendency on the on the part of the person asking the question for you, to lead you to say yes. Right? How about this one? This is a completely opposite. Do you favor a small tax while your tax is used to bail out big banks? Right? That is sort of a negative connotation there, and so these are called loaded questions, and you want to avoid them. And sometimes you see and hear and read about these things. And if you identify loaded questions, then you can say, well, this statistical study is not so reliable. All right, so now we go to the types of statistical studies. And I think I'm going to pause here and then go into the second part of the of this video.